Good morning, guys. Today we're going to talk a little bit more about prime factors, composite numbers, factors in general, and all that fun. So we're going to very quickly go over that again. So remember, when we are talking about factors, factors are two numbers that multiply together to make a product. So the product of 6 and 7 is 42, and the two factors of 42 are 6 and 7. Can you think of any other factors of 42? Well, there's 2. So 2 times 21 would be 42, so there's 2 and 21 in there as well. There's 1 and 42. So there's lots of ways we can make our different numbers. Last time we also brushed gently across multiples. We're going to just quickly talk about that, but we'll come back to that when we go into multiples in a bit more detail on that part of the unit. Multiples are basically numbers that appear on the times table of a specific number. So let's say for number 7, the multiples of 7 are 7, 14, 21, 28, 35, 42. Let's say you think of a number, let's say it's 140. Oh, well, 140 is a multiple of 7. It's 7 times 20, or 27s. Let's say we think of number 4. No, we've already done 42, Teacher Dave. Let's say we're talking about 14. Is 14 a multiple of 7? Yeah. What about 17? Well, 17 is not a multiple of 7. In fact, 17 is only a multiple of 17. That's the only times table that 17 appears on. Speaking of, what kind of a number is 17 if it only appears on its own times table and on one times table? It makes it a prime number. It can only be divided by two numbers, itself and 1. So prime numbers are the special numbers that only divide by themselves, like number 2 and number 3 and number 5 and number 7. Is 10 a prime number? No. Is 11 a prime number? Yes. Then we were talking about factors. So factors are all the numbers that can multiply together to make another number. So the factors of 16 are 12 times 8, 4 times 4, 16 times 1, and we just list all those numbers that come in the combinations as its factors. If we have the same number coming up twice, we just list it once, because we are only interested in in counting or enumerating the factors. All right, the factors of 150. Last time you guys were fantastic at this. You listed all the numbers we can multiply together to make 150. And then we just list those numbers as its factors. So we can do 1 times 150, 2 times 75, 3 times 50, 5 times 30, 6 times 25, 10 times 15. All of which we list as factors of 150. The factors of 17. Now, we just talked a little bit before there about 17 being a prime number. That means it only has two factors, itself and 1, because we can only do 17 times 1, or 1 times 17, to get number 17. All right, so prime numbers, a number that has only two factors, itself and 1. And nope. Okay, those are the nope, I can't do that. The composite numbers. The composite numbers have more than two factors, so you can divide it by something that is not itself or 2, like number 8. We can divide it by, itself or 1, not by 2. We can divide 8 by 1, 2, 4, and 8. 8 divided by 1 is 8, 8 divided by 2 is 4, 8 divided by 4 is 2, 8 divided by 8 is 1. So more composite numbers here. So remember, all even numbers have to be composite numbers as well, because every even number can be divided by 2. You're quite right. Cool. All right. Oh, sorry, every even number apart from 2. 2 is a prime number. And 1 is special. It's not prime, it's not composite, it's just 1. All right. Today, our main topic is prime factorization. Prime factorization is a way to write a composite number as a product of its prime factors. Okay, so a prime factor is a factor of a number that is also a prime number. So let's say we went back to... Oh, we can't go backwards in this. That's annoying. Okay, let's say we were talking about 12. Okay, so we've got number 12. What numbers can we use to make 12? Well, we can do 3 multiplied by 4. Okay, 3 is a prime factor because it's a prime number that's also a factor of 12. 4 is not a prime factor. It's a composite number that is a factor of 12. So if we wanted to do prime factorization, we would have to break 12 down into 3 and 4, and then break 4 down into the numbers, into factors which make 4. So that would be 2 and 2, and we would also put a multiplication there. Okay, right, let's show how we do that. Oh, it does it there. Okay. So a really nice way of looking at this is the factor tree method. So we start by writing down our composite number, so 48 here, and then we think of 2 numbers we can divide it by, or 2 factors. Now we can start with a prime factor, or we can actually start by a composite factor as well. Either way is fine. In this case, we're going to start with 2. So we can divide 48 by 2 to get 24, or do 2 times 24 is 48. Which of these is a prime factor? Number 2 is a prime factor because 2 is a prime number. We can't make 2 any smaller. We can't divide it by any other numbers. Well, we could divide it by 1, but then we would just get 1 times 2, and that's the same as 2. But we can break 24 down further into its prime factors. What's a prime factor of 24 that we can divide it by? Well, that would be 2 again, right? So we can do 2 times 12. So now we've made this number smaller again, and again we've got another prime factor here. Next, we can break 12 down. We can break 12 down into 2 and 6. And then we can break 6 down. 6 can go to 2 and 3. So we've turned our stump, our trunk of 48 into a tree that keeps branching out and branching out and branching out. Now, what we can do then is we can take all the branches and bring them into one single equation. Okay, so this is the prime factorization in the exponent form. So we've taken 48 and we've taken all the prime numbers out of it, the prime factors, sorry, we've taken all the prime factors out of it. And if we times them together, these will all make 48. So 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 3 is 48. So this is the prime factorization, and then we can condense this down into 2 to the power of 4, because we've got 1, 2, 3, 4 2's in our exponent form. So that becomes 2 to the power of 4 times 3. 2 to the power of 4, that's the same as multiplying 2 by itself 4 times. And then, well, 3 technically is 3 to the power of 1, but when you times something by 1, it's just itself. So there's 1 3, so we just write 3, and there's 4 2's, so we write 2 to the power of 4. Okay? Let's try it with number 4. So with number 4, what two numbers, or what two prime factors do we have for 4? We've got 2 times 2. So that's the prime factorization. We bring it to 2 times 2. And then for the exponent form, that would be 2 squared, or 2 to the power of 2, because we've got 1, 2 2's. So the exponent form of 4 is 2 squared. Next we've got 6. 6, we would do, what would we do you think? 2 times 3, yeah. Can we make 3 any smaller? Nope. Can we make 2 any smaller? No. So the prime factorization of 6 would be 2 times 3, because these are both prime numbers, prime factors. Oh, sorry. And the exponent form would just be, again, 2 times 3. This time we've got 27. What prime number can we divide 27 by? Can we use 2? No, it's an odd number. Can we use 3? Yeah. So that would be 3 multiplied by 9. 3 multiplied by 9 is 27. These are both factors. Can we make 3 smaller? No, it's a prime number. Can we make 9 smaller? Yes. That would be 3 times 3, right? So our prime factorization would be, if we bring this 3 down here, it would be 3 times 3 times 3, or 3 to the power of 3, because we've got 1, 2, oh, that's a 2, 3 3's. Okay. Number 12, we've done 12 a couple of times now. That would be 2 times 6, and then 2 times 3, so 2 times 2 times 3, or 2 squared times 3, which equals 12. Now, I know this looks a little bit different from how we were doing it before, but we're just bringing our previous prime factors down with us so that it's easier to see in the prime factorization form. Okay? All right, 18. 18, we can divide that by, well, we could use 2 or 3. We usually divide it by the smallest prime factor that we can, so it would be 2 and 9, and then 9 is 3 and 3. So it's 2 times 3 times 3, or 2 times 3 squared, because we've got 1, 2, 3's. 1, 2, 3's, not 1, 2, 3. Cool. Okay, boys and girls, now we are on DaveCam. I would like you to turn to page 5 and 6 in your workbook, please. So, for each of these, I'd like you to do just as we were doing in the PowerPoint there. So for 10, we write 10 at the top of our number tree, and then we break 10 into 2 and 5. Okay, so we would write 10 equals 2 multiplied by 5. Let's jump to one that's got a bit more. I'm going to jump all the way over to 120. So we can put 120 at the top. Now, you can either go for the smallest prime factor, or if you'd like, you can go for any of the composite numbers that make it up. Okay, I'm going to stick with dividing it by 2 first. 2 and 60, and then from 60 we can go, let me just try and focus a little bit more, there we are. From 60 we can go 2 and 30. From 30 we can go, I'm going to go 5 and 6. Then from 6 we go 2
and 3. Okay, and then we've got to count up all the 2's. 1, 2, 3. Got 3 2's, so we're going to go 2 to the power of 3 multiplied by, oh, we've got a 3. 3 multiplied by 5. Okay, easy as that. So it's just dividing our numbers in our composite number into prime factors and other composite numbers. If you want to do it in 2 composite numbers and then break both of those down into primes, that's fine as well. But this method makes it nice and simple, okay? All right, guys. After you've done this, I want you to do one more thing. I want you to, on a blank piece of paper, or in your primary math notebook, I want you to pick, to tell you what, I think a blank piece of paper would be better for this. I want you to pick the biggest number that you want to do. And I want you to break that into its prime factor. So I'm going to do, how about 3,200. That's a nice simple number. So I'm going to break this into 32 and 100, because 32 times 100 is 3,200, right? Then in 32 we can break into, how about we do 2 to keep it simple, and 16. Very short break from my brain there. 2 and 8, 2 and 4, 2 and 2. Okay. Then we've also got the 100 over here. So 100, I'm going to do 2 and 50. I'm going to do 4 and... Nope, not 4. Come on, brain. We're going to do 2 and 25, and then we're going to do 5 and 5. And then at the bottom, I'm going to write it all out. 3,200 equals, all my 2's, 1, 2, 3, 4, 5, 6, 7. 2 to the power of 7 multiplied by, oh, there's no 3's. Well, there's 5's. 5, and there's 1, 2, 5's. 5 squared. Okay? So when you do this one, if you can just take a picture of that and add it to the group. Thanks very much.